Column shortening analysis is one of the major strengths of MIDAS software actually. So you can do the construction stage analysis and column shortening analysis, and also you can perform buckling analysis, heat of hydration analysis, and with the heat of hydration analysis can be performed with and without pipe coolings, and you can do the boundary change analysis. Boundary nonlinear analysis, you can model dampers, isolator, hook elements, gap elements, and all. And you can do pushover analysis as per RC structures, steel structures, SRE, and masonry structures. Settlement analysis as well as inelastic time history analysis. So these are the various analyses which you can perform in MIDAS Civil Gen. And coming to the design capabilities, you can do design of all types of different types of elements can be designed. In RC design, you can do beam design, column design, slabs, footings, corbels, shear walls, combined shear walls, basement walls, buttress, retaining walls. So every type of things actually means everything is not possible in MIDAS Gen. We have to add on module which is called Design Plus, where you can do all these type of non-structural element design as well. In MIDAS Gen, you can do RC design like beams, columns, walls, shear walls as per different codes, steel design, and also SRC design, steel reinforced concrete design, and also you can do the footing design and slab design. Slab design also can be done as per Euro codes and as per American codes. So some of the project applications where MIDAS Gen has been extensively used include the buildings, the Burj Khalifa, the world's tallest building, and also the Gonja Tin Tower, Hanoi Vietnam Landmark Tower, Moscow City Palace Tower. So these are some of the building applications, and also it has been extensively used in the plant structures like Tavajan blast furnace, Pasco Phoenix, dust catcher. So different types of structures, and also the spatial structures like Beijing Olympic Stadium, Beijing International Stadium, so international airport structures, as well as specialty structures. So MIDAS is a single stop solution for all your structural needs. All types of advanced analysis you can perform for any type of structure, any type of structural material as well. So coming to the today's main point of the webinar is mainly modeling using MIDAS Gen. So we are going through different types of modeling functional. There is a inbuilt modeling functionalities available in the program actually, where you can create the nodes and you can create. Apart from that, we also support lots of import and export functions from different software, which makes the modeling a ease. So today we are going to discuss about importing from AutoCAD DXF both 2D and 3D files, how to import and how to make the buildings and structure in MIDAS Gen, how to import from Revit structures. So Revit structures we have bidirectional actually, so you can take from the Revit model and you can update the model in MIDAS. If you make any changes, those changes can be taken back to those structures again, and also import from Tekla structures and import from eTabs. So both 9.7 version, the old version, and the latest version 2013 and 2015, and also importing from STAD files if you want to import from STAD. Also modeling using built-in functions. So these are the in brief you are going to see. First, coming to the webinar objective, this webinar is mainly geared to introduce the basic modeling in MIDAS Gen. So discussion of the various import functionalities available in MIDAS Gen, live demonstration of all these modeling techniques. At the conclusion of the webinar, attendees will be familiar with the basic modeling in MIDAS Gen. So first, importing from the AutoCAD DXF files actually. So if you're importing AutoCAD from AutoCAD DXF, all the line or polyline in a DXF file will be imported as a beam element. So for example, if you have a straight line in AutoCAD DXF, it is imported as a straight beam element. And if you like a open polyline actually, open polyline which not a closed which a multi thing, that will be imported as a multiple beams actually, multiple beam. And if you're three noded or four noded closed polygon, so those are imported as a plate elements. Closed polygons are imported as plate, not as beam elements. And if you have closed polylines which are having more than four corners, so in that case, that is again imported as a beam element. So everything is imported as a beam element in that case. So only case where you are getting the polyline as a plate element is when it is a three noded or a four noded. Then you import it as a plate element. In all the other cases, the polylines or the line, it is imported as a beam. And surface and 3D face in DXF file will be imported as a plate element. So solids cannot be imported from AutoCAD drawings because solids cannot be imported. Curves and arcs also cannot be imported. So if you have any curved circle, curve and all those cannot be imported to MIDAS Gen. So those things need to be break and exploded in AutoCAD DXF file, and then we need to import the curves and arcs. And also unit system must be consistent between both the softwares. AutoCAD DXF file and MIDAS Gen, the unit system should be consistent throughout the things. And also you also can import the grid lines for your reference, and all grid lines can be imported from the AutoCAD drawings using the dimension option in MIDAS Gen. This is not import functionality to import the AutoCAD dimension grid lines and all. This is a mainly the grid lines works as a reference in MIDAS Gen. So you can import those using a function called dimensions in MIDAS Gen. So we'll go through all these functions in detail. Now first what I will do is I will just go to AutoCAD. Let me take a AutoCAD file. So this is my 3D AutoCAD file actually, if you can see. So this is the typical floor plan actually for the building. So you have the grids at the top. So each grid is named in a different names are given for the grids. And then at the bottom you have the column locations, walls are there. So we have drawn a center line for all the columns. A center line is drawn at the column locations to mark the to put into the MIDAS. So first thing what you need to do is once your center lining drawing and everything is done actually, first thing you need to check is the units. Just command the units. Check the units here in the AutoCAD drawing actually. What is the units in the AutoCAD drawing? So these units should be consistent between AutoCAD and MIDAS Gen. And again, if you are trying to import multiple floor levels, actually multiple floor levels from AutoCAD DXF, each floor plan is different and you want to try to import, then all the floors should have the one common point should be there, which should be aligned for all the floors. If not, then it will be taken at different positions. So you should there are a couple of things you need to consider is the unit system consistency. The second thing is the base point for all the AutoCAD drawing should be the same for all the floors. Now, once this is the unit system is matching, now what I can do is I can go to MIDAS Gen. So first I will go to File, New Project. So I'm opening a new project. So directly I can go to File, Import, AutoCAD DXF file. Just I need to browse the DXF file. So just I will go to Browse, DXF Import, Floor Plan. I selected the plan which I want to import, floor plan. And here that the center lines I want to import the center line. I selected the center line, the layer which I want to import. So if you have say if you have different beams of different sizes and all, so if you can put it in different layers, so each beam is grouped automatically in as per the layer name in MIDAS Gen. So it will later it will be more useful for you to assign the properties and all. So I just added the center line. So the material properties, just I click on the three dots next to that and I say add concrete EN04RC and I select C25 by 30 grade of concrete and I would say OK. The material property is calculated. The section property, add beam, solid rectangle beam, user defined. The height is 0.5 meters and the width is 0.7 meters. OK, close. And here I am changing the unit system to mm because our DXF file the unit system are in mm. So here I am also changing the unit systems to mm. So once this is done, what is the origin point? You can define what is the origin point. This is the floor plan, the first floor plan. So I want to insert it at the floor level, not at the origin level. So in the Z direction, it should be at 4 meters. My first floor height is at 4 meters. So I gave the origin as a 0, 0, 4. That is X and Y is going to be 0. And in the Z direction, it will be at a 4 meters level. And then if you want any rotation angles and all, you can say if you want to how, and you say, okay. See, my floor plan is imported. Now for locating the column locations and wall locations, if you have the grid reference, it will be more easier to immediately pick the column locations and all those things. So for that, what we can do is directly go to the structure tab. There we have option dimension. Now the dimensions, you go to the dimension, say dimension name. Let me say first floor. The grid name, I want to give the grid name actually, so I'm giving, and I'm just selecting the same file again, the floor plan again. So here actually for the dimensions, all the points, the grid lines and the grid marking, I put it in a layer called dimensions. So I selected the dimension. So I can select what is the scale factor, what is the origin point and all, and then I say add, and I would say close. So here if you see now, here you have the origin point with all the dimensions and all those things actually. Let me zoom in a little bit. So you can see what exactly is the dimension as in AutoCAD dimensions, and you can see the grid lines actually. So this is exactly as per the AutoCAD. So here actually the one thing is like you cannot edit anything in the grid line. You cannot select the grid line also. You cannot select the grid line. You cannot edit the grid lines. Just you can switch it there, turn it on and turn it off actually. Say display and display. Just you can display and you can undisplay. So that is just for your reference purpose. You cannot make any changes to the grid line layer. If you want to make any changes, you need to do it in AutoCAD and you need to import it from there. Once it is in a MIDAS gen, it is like a freezed out layer, so you cannot make any changes there actually. So that is just for your reference. So based on this reference, once I have the grid lines, what I can do is first I will define a property for the columns. Say add sections, solid rectangular, column, user. Say column is 500,000 by 750. Okay. So I can select the nodes where the column locations are coming with respect to the grid line. I can select the nodes where the columns are coming actually. So on the grid points, so I'm selecting my column positions. So I'm selecting the nodes in the columns. So what I can do is once I select the nodes, actually I can extrude these nodes for generating my columns. So I selected the nodes actually where the columns are coming. The columns are selected. Now I go to the properties. So node by element, extrude, node to line element, and it is the element type is planar element or beam element, and the section property is column, and unequal distance in the z direction. Say let me say it is 4004 meters, that is 4000 mm, and I would say apply. Sorry, it should be minus 4000 actually. So what I will do is select previous, say minus 4000, so that in the negative direction I would say apply. So here the columns are generated actually. So the columns are generated even for the core walls also. Similarly we can do the same thing. So core wall locations, the walls, wherever the walls are coming actually. So in those regions I'm going to select the walls for my walls, the core walls. So this entire end triangle regions are the walls here in this drawing. So I'm selecting those wall regions, the end walls, and then the central core wall region. I selected all the core walls actually. So here what we can do is it is to be line to planar element. The wall is a planar element. So I say line to planar element. It is a planar element, and I don't want the source beams actually. So I say remove. I don't want the beams. I will be removing these beams, and the element type is wall type. It is a wall. So I can select the thickness of the walls. Say 500 mm thickness. I would say okay. Okay. Now you can select either it is a membrane type of this thing or a plate. So what type of action you want? When you say membrane, there is no out of plane bending. In plate element, there is out of plane bending is there. So you can select what is the type of the bending you want and then translate in the z direction minus 4000 and I would say apply. So you can see my floor plan is generated. So now I can go back and I just switch off my grids and display. So now once your floor is generated, what you can do is from here you can go on with the building generation option. If your floors are symmetrical, typical floor for all the buildings. So this floor, this building actually has a typical floor. So in that case, what I can do is I can directly go to the building generation. So I have 16 floors above this, each one of 3.15 meter height, 3100 height actually. And I would say add. I would select the complete building and I would say apply. So the building is generated. So here a couple of things you need to understand is before generating the building, if there is a loadings and all are there, I can apply all the loadings on the typical floor itself, and then I can generate the building. So in that case, what happens is my load and everything gets copied to all the floors. Or the other case is after generating the building, so you can also apply the loads on this building right now. So loading and all we will be discussing more in detail in the next webinars actually, where we are going to do a series of webinars. So this today's webinar I'm going to concentrate only on the modeling, how to generate a model, how quickly you can generate a model in MIDAS Gen. So this is one way of importing a 2D DXF file and then a grid lines, reference grid lines, and then based on that how to pick the column locations, wall locations, and generating the drawing. So the second way of importing the drawings from AutoCAD is it's not only the 2D file, you can also import directly a 3D DXF file. So for example, you have a 3D file in AutoCAD DXF, 3D model. So this is a 3D model with a 40-story structure. So I can directly import the complete 3D structure itself with all the columns, slabs and everything from the 3D model. So the procedure is the same again in MIDAS Gen actually. So the procedure, there is not much of a change. So again here also we need to, first thing is we need to check the unit systems. The unit system should be consistent between these two. Say unit is units. So it's a unitless system. I'm changing it to millimeters and I would say OK. So now I go to MIDAS Gen. So I would say new file, new file, file, import, AutoCAD DXF file, browse. I mean, see, browsing the 3D DXF file. So in this 3D DXF files, what I did is I created different layers actually for my beams 350 by 750, the beams 400 by 800, beams 450 by 900. I have different layers. So here one advantage is there when you are importing, there is no need to import everything at a single go actually. So first let me change the unit system to millimeters. Yeah, millimeters. So first let me select the slabs. So I selected the slabs and I'm going to the material, add a material, say concrete. My slab is of 30 grade, so I selected 30 and I would say OK, close, and the thickness of the slabs add 250 mm thick, 250, OK, OK, and I can click apply. So all the slabs are imported with the given thickness actually. So if you have different thickness of the slabs, if you generate different layers in the slabs also, you can import one by one by assigning the thickness and everything while importing itself actually. So another, now the slabs are imported. Now what I will do is I will go for the beams, say 350 by 750 beam. So I will just go to the section, add, say solid rectangle, beam, user, 350 mm by 750 mm, the beam, sorry, 750 is the width, height, and 350 is the width. OK, OK. This is my beam 350 by 750 and I would say apply. Sorry, it should be in mm actually, the units. Okay, the unit should have been in meters. Okay, now you the beam properties, just I would say beams and I would say apply. So the beams are imported. Similarly, you can import each and every layer by giving different properties. You can assign each and every layer and you can import the, we can so import the things from here actually. Or the other way of doing this thing is, what I can do is just let me undo the complete model. Instead of selecting each and every element separately and updating all these things again and again actually, what I can do is directly, just let me select all. Okay, so one the other thing what I can do is just directly I can go to file, import, AutoCAD DXF file, say browse, 3D DXF file. I can import all layers in a single go without assigning different properties and all. I select all the layers and I just give the thickness for the slabs as 250, and for the beams maybe I create only one single property actually. So solid rectangle 350 by 750 beam. Say user. So what happens in this case is all the beams which are being imported, they will be having the same property. So I would just say okay. So imported the complete model. Now for each beam layer name is created as a separate group. So once the model is imported here, you can select the group and you can assign the properties, required properties. So that is the other way of modeling when you are importing a 3D file. So one is you select each layer wise and give the respective property and import that each layer wise you can import, or you import the complete model. So each layer is created into group. Later after the model is imported, then you can give the properties to the groups. Select each group and assign the properties. So as it's a 3D, it's a big structure actually, it is taking a little bit of time. So here the model is there, complete model is there actually. So let me say it is. Okay. Now here you can see actually. So all the beams, all the columns, all everything have the same property actually, which we have given in the previous location actually. So here what you can do is just if you right click tree menu 2. So here you have the groups. So here you can see the groups. So each layer is created into a group. Now what I can do is I can go to the section properties, add sections. Say directly I can go to the solid rectangular. Say EC 1000. So that is the user. It is solid circular column. Say 1000 actually. Apply. Similarly, I have EC 1100. EC 1100. So I would say apply. Similarly, EC 800. So I can go on creating the properties actually here. So once the properties are created, what you can do is directly you can come here, double click on the layer here in the groups. Double click. Those elements are selected in the model. The red color highlighted one are the elements. Just drag and drop the required property there. So the properties are changed. So double click, drag and drop the required property. So in that way you can do the assignment of the properties actually. Click, drag and drop. So this is one way of changing the properties and all. So one is while importing you can give the properties and all, or after importing you can give the properties and all. So this is in brief about the AutoCAD import functionalities in the program. Either if you are importing a 2D file and creating a building, or you are importing a 3D location. Now I have a couple of queries on this features actually. So if you have any questions before going further with the Revit structures, if you have any question regarding the AutoCAD, what we have discussed, you can ask me now. One is from Mr. Levi Cuno. Why the Z coordinate is in meter while the dimensions are in mm? Sir, actually when I stayed import at the time, what happened is actually the unit system is in meters. So I entered the Z axis in meters actually, say in 4. So later before import I changed it to mm. So when I change it to mm, you can see the value will also change to mm actually. It automatically converts to 4000. So that is just a mistake from my side actually. Before changing the units, I entered the dimensions. So later I changed the units. So there is no need to worry actually. Even the coordinates, if you enter in one unit, later you are changing the unit to some other unit, the value will be automatically updated. Okay. Now here you can see it is showing 4000 in the origin. So if I change again the units to meter, it automatically comes back to 4. So that is automatically taken care. Okay. And coming to the other question, from Mr. Rafid Atra, how can we choose the correct principal axis? Sir, principal axis, once if you know the principal axis in AutoCAD X and Y, XY direction, Z axis is the vertical axis in AutoCAD actually. So if you have different axes, actually, we have the rotational functionalities in the program. So for example, your drawing is not exactly in the XYZ coordinates in AutoCAD actually. Maybe in AutoCAD, your Y coordinate is the vertical. You kept it as vertical, and X and Z, you kept it as horizontal. So in that case, what you can do is when you are importing the model from AutoCAD, in MIDAS, we have this rotation angle, Rx. Means it rotates the model with respect to the X axis. Ry, it rotates the model with respect to the Y axis. Rz, it rotates the model with respect to the Z axis. So you can give the rotation angle, you can manipulate from here actually. So if it is in the XZ plane, so here it is, we want that in a XY plane. So that is, we need to rotate it in respect to the Y axis 90 degrees. So you can give 90 degrees with respect to the RY rotation, then your plan will come in the XY plane here. So that way you can manipulate the principal axes from between AutoCAD and MIDAS Gen. And the next question is, how can we believe this is the critical axis? Sir, critical axis, that way actually there is no right way to say, but you need to check both. You need to first check the AutoCAD drawing, what is the plane, in which plane your floors are laying in the AutoCAD drawing. So either it is in XY plane or XZ plane. So that gives you idea along which axis we need to rotate. So for example, if it is in XY plane, so in MIDAS also the vertical plane is XY plane. So there is no need to rotation. But if your AutoCAD in AutoCAD, it is your plan is in XZ plane. So we need to rotate along the Z axis, that is the vertical axis. Should be rotated along the vertical axis so that you can get it in a plan form, that is XY plane. So you need to rotate along the Z axis. So that you need to compare both AutoCAD and this thing, and the engineer need to come to that judgment, sir. Which axis, how the rotation will be happening. Hope this is clear. Okay, now let's go to the next part actually. So as I said, actually one thing also, when you're importing the grid lines, those are for references. You cannot change anything in the grid lines, and the unit systems between both the drawings, both AutoCAD and the MIDAS Gen should be consistent, and curves and arcs cannot be imported, solids cannot be imported. 3D face and surface in DXF will be imported as a plate element, and closed poly 3-noded and 4-noded closed polygons are imported as a plate elements, and all the other types of lines are imported as a um, solid elements actually. And another question from Mr. Amar Dosari. What about the openings in slabs? Sir, if you're providing an opening, say if you're modeling the slab as a, for example, if in AutoCAD, if you're modeling the slab as a 3D face and you're providing an opening in that, the opening is also taken care by the program. Automatically, it will import the opening as well. If it is modeled as a 3D face. But if it is modeled as a closed polyline, again, internally, you need to create another polyline actually, which is not a polyline, which is 4 lines, which makes the boundaries of your opening. So in that way, you can take the model from there. Like that, you can take the openings in the slabs. If it is a 3D face, you directly model the openings in the 3D face element itself. If it is a polyline, closed polyline, then create a boundary inside that closed polyline with lines, not a polyline with lines. So then the openings can be imported. And another question from Mr. Livy QNO, how the arc elements be manipulated in importing to MIDAS from DXF? Sir, arc elements, one thing is we need to break it into smaller parts, either by using the explode function, or we need to break it into smaller parts, arcs, circular elements, curved elements. These need to be broken. So once you broke into small parts, you can take into the here. Yes, sir, arc to multiple lines. You need to convert into multiple lines, the arc. Okay, Mr. Rafid Atra, he has another question. If you have irregular plan, how can we direct the correct principal axis? Sir, you are talking about the plate principal axis after getting into the MIDAS Gen, or exactly, I'm not able to get your question. If it is a plate principal axis after you're getting into the MIDAS Gen actually, so that you can manipulate in MIDAS Gen itself. We have a functionality in MIDAS Gen where you can select all the plate elements and you can align the principal axis in the direction which you want. All the slabs, plate elements, or the beam elements and all. Either it's irregular plan or regular plan. That I will show you in the last, at the end of the presentation. I will show you in the modeling how this can be done, the principal axis for the plates. Okay, now coming to the import from the Revit structures. So when you are importing from the Revit structures, complete structure with all the beams, slabs, walls, openings, doors, and everything can be imported from the Revit structure. The structural columns, beams, braces. So in the Revit structure, the link is a bidirectional link. But the bidirectional to work, actually, the first initial model should be in Revit. So once your Revit model, you can import that model to MIDAS Gen. And whatever changes you are making in MIDAS Gen, those things again can be taken care to MIDAS Revit structure actually. So you can import structural column, beams, braces. You can also import the planar elements like foundation, slab, structural floors, wall openings, vertical shafts, boundaries, different types of offsets, rigid links, cross sections. Loads also can be imported, load cases, load combinations, point loads, materials, levels. Everything can be imported from a Revit file actually. So here this is the general workflow for a Revit file actually. First you need to have the prepare analytical model in Revit structure. So your initial model should be there in the Revit structure. So and then you need to export the analytical model to MIDAS Gen. Means that is exported as a MGT file is generated. So once the MGT file is generated, import the MGT file to MIDAS Gen and perform the analysis, design and optimization. Once you are done with your design and optimization of the sections and all, you export the updated MIDAS model file to MGT file again, and you call this MGT file into the Revit file for updating the model. This is the workflow generally. So just I will show you a brief demo of this workflow actually. So first let me close AutoCAD. Okay. Okay. Just let me open Revit. Okay. So this is the model in Revit actually. So if you say this is the not analytical model, this is the Revit model, like general normal model actually. So if you click on any slab, you can see what is the 250 thick floor actually. This is the 250 thick floor, level 6, and here you can see the other parameters, what are the things and all. Similarly, you can click on the columns and you can check what is the size of the column, 400 by 400 column. So similarly, if I go down actually in this plan and I can just click on the analytical model. So this is my analytical model actually. So analytical model, it consists of the loads and everything. So if I click on any slab actually, so here I can come to the live load. This is the live load case is there, live load in FZ direction, it is minus 3 kilonewton per meter square. So you can check the loads and all. So the only you cannot take the architectural model or structural model from Revit to MIDAS. It should be analytical model. So you need to make the analytical model. Once the analytical model is made, before taking to MIDAS, you need to analyze the analytical model. So if you go to the analyze tab in in Revit, you have different options here: analytical adjustment, analytical reset, check supports, consistency checks. We need to perform all the consistency checks actually. So there are many tools are there actually, consistency checks. So you need to check either if there is any inconsistency in the models and all. So if there is any inconsistency in the Revit, those things are carried over to the MIDAS Gen. So this is the first check you need to do before taking any model. So you have different types of consistency checks are there. So you can go here, what are the load cases, what is the load values, what are the load combination, analytical model settings, so circular references and boundary condition settings. So everything you can check from the here. Once this is done, you can go to the add-ins. So here in the external tools, we have this option: send model to MIDAS Gen, update model from MIDAS Gen. So the link for the Revit to MIDAS, you can get it in the MIDAS installation folder. So once you install the MIDAS software, you go to MIDAS Gen for installation folder, local the C drive, program files, MIDAS, MIDAS Gen folder. So there you have the option called MIDAS link for Revit structure. There will be a folder. So if you go to open that folder, you have the links here. So Revit 2015 32-bit, 64-bit, Revit 2016 32-bit and 64-bit. So just click on that based on your version of Revit, you can directly click, and there is a setup file. You can click on the setup file. The link will be installed. So once the link is installed, then you can go to Revit add-ins. In that you can go to the external tools. There you can see this option: send model to MIDAS Gen and update model from MIDAS Gen. Both the options are available from here. So just I'm saying send model to MIDAS Gen. So here once you are sending the model file, this is the Revit model file, RMG file. It will write a Revit model file in a text format actually, and then it will write the Gen model file actually. So it is by default it will be storing in the folder where you are saving your MIDAS Revit model. So if you want to change, you can click on browse and you can change the model file location, saving location, and then the element size means the slab element. Either you want to go for a fine mesh, normal mesh or a coarse mesh. So the program will automatically do the mesh. So based on the number of slab elements you are having and based type of the meshing you selected, the conversion time may vary. So here I'm keeping it normal. So here the export target, there is no need to enter all the time. You need to import the complete structure. If you want to import only specific part of the structure, so that also you can do that one actually. Export target all are visible objects only in the current view. So if you check that one, only the visible objects in the current view will be exported. So force units, you can select what is the unit system you want to do. And then mapping, section mapping. See, section mapping is automatically done by the program, or if you're using any new section and all, just you can go to auto search. So identical name, when you say identical name, for example in Revit, if the name is HA 500 and in MIDAS also it is HA 500, if the names are same, it automatically map those sections. If the names are not same, actually in that case what you can do is you can go for user defined sections, user defined, and you can define your own mapping actually. Say if you are using any non-standard sections or built-up sections, then you can try to use the mappings. But by default, all the standard sections as per different codes, American codes, European codes, British codes are all already mapped in the program. So if you are using any other section, then if you need to do the mapping, you can do the mapping here. So similarly, material mapping, it's also done by default. So if you want to do any other material mapping, you can go to the add and you can do the material mapping. So just click on add. So you can select the Revit database material. What is the material in the Revit database? Say for example, you want to say concrete. Concrete type in MIDAS, it's also concrete. Standard, which code you want to standard, and what is the DB. So we need to do the mapping here. Okay. So if you are not doing the mappings and all, actually the proper mapping is not done. What the program will do is it will take the default material property available. It will take the default material property and it assigns the default material property to all the members. Sorry. And now I'll click send. So it is exporting the model MGT file. So here actually what it is doing is already it takes all the sections, whatever the sections are given, it automatically it takes from the mapping rules which are already defined. If there is anywhere, if program is not able to exactly identify the section, it will give it as failed. Here in the result part, what you are seeing okay will come as failed. So in that case, you need to select that one and you say define section mapping, and you can do your own personal section mapping. And this is like a one-time process. Once you do this section mapping, so that section mapping is stored in the mapping file, and next time onwards it automatically recalls the same thing. So first time when you face the problems, you need to do that, and then you say continue. So it's done. Now if you go to the folder where you have saved the Revit model file, actually Revit, so here you can see concrete structure.rmg and concrete structure.mgt file actually. So if you open this MGT file, this is the text file, MIDAS gen text file actually, with all the coordinates and all those things for the Revit model. Now you can go to MIDAS gen, say file, new project, file, import MIDAS gen MGT file. So just I go to the desktop, MIDAS gen webinar, Revit. So just opening the file. See here, the model is here. So as I selected the normal mesh, the mesh is not fine. It is a coarse mesh actually. So it's all depends on the type of the meshing you are selecting there actually, or if you want to upgrade the meshing, you can do it here also, the meshing and all. So once the model is here actually, say for example, I have the slabs are 250 thick and the walls are 2 or 300 thick. What I can do is if I want to change the thickness of the slabs for 200 mm. So after the model is imported to MIDAS gen, I'm changing some changes here. So I change the slab thickness to 200. I would say okay. Now what I need to do is, if I want to update the model again in Revit, the first step is we need to go to file, export MIDAS gen MGT file. So and I give a name, concrete modified. Just I'm exporting the file and I'm saying it is a modified file. Save. So it is saved actually. Now I go to Revit, Revit structures, external tools, from the same location, add-ins, external tools. You can say update model from MIDAS gen. So here you can select the Revit model. So while exporting the model, it created one RMG file. You need to select that RMG file and then you need to select your modified model file, concrete modified, the modified model file, and log file is automatically generated by the program. So you say update. So here it gives in the log file, it will give modified thickness 1 complete, sections 0 complete, modified material 0, deleted element 0, added elements with default section 0 skipped. So it will give the complete summary. What are the changes happen in the model? So whenever you are updating any model from MIDAS to Revit, always check this log file to be sure that everything is taken properly. So once this is done, you can say close. Now here you click on the slab. Actually, if you click on the slab here, say just let me go to the 3D view so we can see the thickness. Just click on the slab and let me come down. See here you can see the thickness is 200 mm. So the thickness is updated. So similarly, it's not only about the slab thickness, you can import the column section changes. Everything can be updated in Revit structures. So it is a bi-directional link. So but it is a bi-directional, but the initial model should be there in Revit structures. Then only you can import it to MIDAS Gen, and then you do your updations, optimizations, and all, and then you can take it back to Revit. But if you have your initial model in Revit, there is no direct way to take it. So if your initial model is in MIDAS Gen, you want to take it to Revit, then you can use it by IFC file format. You can take it to Revit. So you go to MIDAS Gen, export to IFC, and take it to MIDAS Revit. Now think some of the things to consider when you are doing the Revit updates and all Revit things. If assigned section is changed to other predefined section in the model, the corresponding member in Revit will be updated automatically. So for example, I have some steel sections, especially this is useful for steel sections. Say I used a section HEA 200 and there is a predefined section which is HEA 300. I am changing this HEA 200 to 300. Then it automatically updates. The Revit structure will automatically updates. But if assigned section is changed to other newly added section in MIDAS Gen, the corresponding member in Revit will be assigned to a default section. So if it is not a predefined section, then the section will be assigned to a default section. So when sections assigned to an element is modified, the family and type name of the element will not be recognized. This means that any sections that may become necessary should be preloaded into the Revit project before sending the model to MIDAS Gen, so that their family and type can be specified during updating the model. Otherwise, default family will be assigned. So this is one important consideration. And if your material data assigned is modified in MIDAS Gen, default material will be assigned in Revit. And before sending a model from Revit to MIDAS Gen, check and make adjustment to the analytical model to ensure consistency. And through nodes and elements may be added, and you can add n number of nodes and you can add n number of elements in MIDAS Gen actually after importing the model from Revit. But never renumber any of the member numbers, because in this operation of taking from Revit and giving it back to Revit, the program identifies based on the member numbers. So if you do the renumbering of the members in MIDAS Gen, then you cannot update the model back to Revit. So you can add new elements, you can delete the elements and all those things, but you don't renumber the elements. That is a must. Okay. So this is in brief about the import of the Revit file to MIDAS. This. Is it possible to include parking ramps to be imported to MIDAS Gen? Yes, sir. You can import the parking ramps, also inclined slabs. It is imported as inclined plate elements. Yes, you can do that. You can do that one actually. So any questions from the Revit import? Okay. Now let me go to the import from Tekla structures. So Tekla structures, actually I don't have a Tekla structures with me. So what I will do is I will just run a small video file for you and I will explain you what are the things going in that video file. So with Tekla, the link is bidirectional. When I say it is a bidirectional, initial model can be in MIDAS Gen or it can be in Tekla. So if your initial model is in Tekla, you can take it to MIDAS, you can do the optimizations and all, and you can take it back to Tekla, or if your initial model is in MIDAS Gen, you can take it to Tekla. So this link works both ways actually. So just this thing, the traditional BIM concept. So once this is the model in the Tekla structures actually. So the offsets, the beta angles and everything will be imported from the model file. So you select the members actually, you can see the members offsets and all. So if you see the beams are laying on top of each beam actually. So this is taken as the offset command in MIDAS Gen actually. So first we need to create the analytical model. So it's the same in both MIDAS Gen or MIDAS Tekla or Revit structure. It is the same. You need to first create the analytical model in those softwares, and the analytical models only can be imported to MIDAS Gen. So the Tekla structure, the loadings. So you can import the loadings also, the load values, dead load values, the load group name and the load case name can be imported. The loads are getting updated. So once the loads are updated, first we need to generate the MIDAS file analytical model. So we are generating the analytical model. So giving the conditions, what are the condition, how it should be converted. So finally I'm selecting the MIDAS. Select the complete model. So now go to the analysis and design models. So there you need to create a new model. The analysis model name. You can give the MIDAS, 2 MIDAS or any name actually. 2 MIDAS. So full model or the by selected parts or the again you can select like this, and you can select what is the auto detect, and then here you need to select the analysis specification MIDAS 2.1 net. So that is the specification you need to select. Once the specification is selected, you can give analysis model rules and all those things. Curved beams split into 8 segments. Sorry for that. So curved beams will be, you can select how you want to take the curved beams. Either you want to split into 8 segments, 16 segments, how you want to split the curved beams and all. So give all those materials, the analytical model will be generated. So once the analytical model is generated, you can check the analytical model in Tekla itself. Again, for inconsistency, you need to check in Tekla the analytical model. So again, in the analytical model, again you can delete the members, or you can add members. You can modify the loads and everything in the analytical model. So once the analytical model is ready actually, so you can give the beam and releases, beam and offsets, beam and conditions and all those things. So once those things are ready, just you can say export to MIDAS Gen. So the export is being done. So once the export is done, so it creates a MGT file similar to what you have seen in Revit. Here also it creates a MGT file. So once the MGT file is there, go to MIDAS file, import, just import the MGT file. See, your model is ready in MIDAS Gen. So the offsets and everything is are automatically taken care. So if you make any changes or anything, that can be again taken back to Tekla structures. So this is in brief about MIDAS link with Tekla structures. Now going forward, so a couple of other things actually before going into how to generate a model using the built-in functions actually, I would like to discuss couple of other import actions. Up to now, what are the import functionalities we have discussed? They are about the more about the BIM, how to implement MIDAS Gen in BIM. Sometimes you already have some models created in ETABS or STAD which you want to compare in MIDAS. So how to import those files actually? So import from ETAPS, actually there are two types of versions are there. Import version 9.7, the old version, and the latest version like 2013 and 2015. So for ETAPS 9.7 files, actually there is no direct import functionality. In ETAPS, first we need to export those files as SAP files, S2K file, and then the S2K file can be imported to MIDAS Gen. Whereas for ETAPS 2013 and 2015, we have a converter created actually by MIDAS, by using which you can directly import the model files from ETAPS to MIDAS Gen. And when you are importing, couple of things you need to remember is the section scale, stiffness scale factors are not imported. So those things need to be given again. And the wind and seismic loads are not imported. Means in most cases the wind and seismic loads are imported, but it is not imported at the center of the diaphragms and all. It is imported as a point loads. So we need to delete and we need to regenerate. I will show both the examples from 9.7 and this. So Windows 9.7, this is the structure, simple building structure which I created. In Windows 9.7, this is the floor plan. Each floor plan wise you can see the plan. It is 17 floor structure. This is the 17th floor plan. So and I can see the other different plans actually. Different floor plans, the loading is one way, two-way loadings. So different plans and section properties. So for exporting this model to MIDAS, the first step is you go to File, Export, Save Model as SAP 2000.s2k file. Okay, sorry for that. So export, save model as SAP 2000.s2k text file. So click on that. The analysis model is being created and it is asking the name for the exported model. So I'm saying I'm giving a name export gen and I would say save. So the S2K file is saved actually in the same folder where you have the ETAPS model file. In the same folder you have S2K file saved. So once the S2K file is saved, actually directly go to MIDAS Gen, file, new project, file, import. You need to go to import SAP 2000 V6 V7 file. Say in ETAPS actually up to the 9.7 version, actually in the 2013 and 2015 there is no conversion for SAP file is available. In the previous version SAP file conversion is available, but the converted file is not into a latest version. It generates a SAP V6 or V7 file. So we are going to import using the V6 V7 file. Click on the V6 V7 file. So click OK. Just go to the folder where you have this file, export gen.s2k file. That is the file. Just click on the file and you say open. Here the model is in there in MIDAS gen. Your slab elements, and you can see the text file open. So here if you can see for the warnings, which are if there is any version which is not implemented, and all those warnings will be available in the text file. So this is your model. So here couple of things we need to understand when you are using the SAP file and importing. Actually there are your geometry will be there, your section properties, plate thickness, the loads, dead loads, live loads, everything are imported actually. But if you see in ETAPS and MIDAS Gen, we have the concept of diaphragm action, where you can define it as a diaphragms and all. But in SAP there is no concept of diaphragm actually. So what happens is when you are exporting a ETAPS file to MIDAS SAP, actually the program what in SAP it does is it first finds out the center of a mass for each floor, and then it creates a node at that point and it connects all the remaining nodes in that floor by using rigid links for taking the rigid diaphragm action. So if you see here, actually there are rigid links at each and every floor. Say let me activate any one floor actually, so that I will highlight this thing. So here if you can see, let me say, let me hidden view. Okay, so here you can see the rigid links being highlighted. So this rigid link, this is nothing but the diaphragm action, but in a in SAP, as I told, there is no diaphragm concept actually. So that's the reason the program is converted into a rigid link and the rigid link connection for each diaphragm action actually. So in this case, what you can do is one thing, you can keep it like this and you can run actually. Internet పోయిందా? So here the rigid links actually, one thing in MIDAS Gen, once you define the story diaphragm story actually, the rigid links are automatically, rigid diaphragm action is automatically taken care. So what you can do is you can delete all the rigid links here. Delete the rigid links, directly right click on the rigid links, delete. Now the second thing is beam and offsets. What exactly in ETAPS it does is whenever you model any pier and then the beam actually, the beam is taken by default at the face of the column actually. It's not at center line. Whereas in SAP it is center line to center line. So what exactly it does is when you are importing a model from ETAPS to SAP, it creates offset for each beam such that the offset is nothing but the up to the face of the beam in the longitudinal direction of the beam. So here also in MIDAS Gen we don't require those things. So we can delete those things also here. Delete these beams. So once deleted, you can go to the structure, control data, story. So click on control data, story, and you say auto generate story data. So it generates the story data and you say OK and you click close. So now if you want to check the rigid diaphragm action and all diaphragm action, so directly go to the display, view, display, and you click on the boundary, story diaphragm. So here you can see the diaphragm is automatically taken by the MIDAS Gen. And here another couple of things are, all the loads are also imported from a ETAPS file actually. But if you see your dead loads and live loads are okay, but if you check your wind loads and all, those are imported as a nodal loads actually. So it is not exactly as per the wind definitions is not imported. So in this case, either you can keep it as a nodal loads or you can delete the wind loads and you can again define the wind loads and seismic loads in MIDAS Gen, or you can keep it as it is and you can run the model. Okay, this is in brief about importing from ETAPS 9.7 version, the old version. Now for ETAPS to the latest version actually, so there is no import or export functionality to SAP actually. So for this versions ETAPS 2013 and 2015, we have created a converter file actually. So you can go to the converter, you open the converter. So here actually directly you can read the EDB file. There is no need to export to E2K file or any file format. Directly click on read EDB file. Go to the folder where you have the EDB file. Just select the EDB file and say open. So the program will automatically does the conversion in the background actually. Convert, it will convert and it will create a MGT file for you for importing to MIDAS Gen. Okay, conversion is done. Now if you go to the folder where you have saved the file actually, so there you can see MES with the file name, with the same file name you have the converter generated actually. So what you can do is to go to MIDAS Gen, file, new project, no, file, import, MIDAS Gen MGT file. Yeah, here you can see actually complete model is there. So here also you get the geometry, the plate thickness and everything actually, and all your gravity loads like pressure loads, element beam loads, nodal loads, all the loads will also be imported actually. And also the story definitions and all are also automatically taken from the ETAPS. The story definitions, The name of the story names and everything are taken from ETABS. So there is no need to define the stories and all the boundaries. But here in this case also the wind loads are not imported here. The wind loads and static seismic loads are not imported. So we need to generate the static seismic loads and wind loads again in the ETABS in the MIDAS gen file. So this is how you can import the ETABS files to ETABS to MIDAS gen. So any doubts in this? So there is one question from Mr. Amar Dosari. Do we need to adjust the unit or to be taken care of the units? So there is no need to adjust any units actually. So by default the program will take care of the units, because when you are reading the text file actually, the first command in the text file is the units. So from there the program picks the unit system. So there is no need to worry about the unit systems. And there is another question from Mr. Rakan Hidwani. I have tried the converter from ETABS 13 to MIDAS, but it did not work on any model. Sir, actually, one more this thing is there actually the converter which is there ETABS 2013, that is for 64-bit PC. So if you are facing any problem, just check either you are using 64-bit PC or it's a 32-bit PC. It doesn't work on 32-bit PC. It works only on the 64-bit PC. Sir, if it is 64-bit PC, just send me the model file. I will check and I will get back to you, sir. Because I checked in my system, it is working fine. I will check and I will get back to you. If there is any problem in that, just get back to me. Okay, Mr. Rakan, I will check and I will get back to you. So you are saying it is not working for you. I will check and I will get back to you. After the webinar, I will talk to you. Okay. So any other queries regarding the ETAS import to MIDAS gen? So here, as I said in the presentation, the section stiffness scale factors are not imported and wind and seismic loads are not imported. The geometry, the beam properties, slab properties, section properties, and then the loadings, the gravity loads are imported. The section stiffness scale factors and those things are need to be redefined again in MIDAS gen. Now importing from STAD. So here the import supports all versions of STAD files actually. If you are using any version of STAD, it will be supported. In STAD actually, for the member beam, shell and solid, you can have the same ID. But in MIDAS, it is not like that. Each ID is different. So everything is taken as an element. So you cannot have the same ID for the beam as well as a plate element. So if member, shell and solid have the same ID, warning message is printed out and the program reassigns the IDs and imports. So no need to worry if the stat file, your member elements, beams and the shells and the solids have the same IDs. It will reassign. The converter will reassign those IDs and it will import the model. And as of now, the steel database sections, when you search steel database, only ASC database is it's supported. And floor loads defined with X range, Y range are not converted. And wind loads and seismic loads are not converted. So just let me show you how to import a stat file actually. So if you have any stat file actually, so this is a stat text file actually. See all the node coordinates and everything actually. It's a raft plate model actually in stat. So just what you can do is there is no need to do any conversion or anything. Directly you can go to MIDAS gen. Directly go to the MIDAS gen program. Open MIDAS gen program. So once you have the MIDAS gen, just click on new file, file, import, stat 2000 std file, file, import, stat 2000 file. So just click on that. OK, and you select the start file, and you say open. So database, it will ask ASC section database. Either you want to use ASC or ASC 2K database. You just select. If it is mainly matters for the steel structures, for concrete and all, it is not. It doesn't matter. So select the database and click OK. The conversion is taking place. Sorry. So conversion is done. If you have any warning message, the warning messages are displayed here. So you can see warning line, corresponding command cannot be converted. The stat space command cannot be converted. So whichever commands are not be converted, or if there is any problem, if the program was not able to convert any sections, everything got displayed in the warning messages here. So once you see the warning messages, similarly here itself you can check the input stat file and output file. If you click on input file, stat file, it opens the input stat file in the text editor. Similarly, output file MGT, it opens the output MGT file in a stat text editor. So if you want to compare side by side, you can compare. And if you want to save this message window, just you say save convert result message. So this will be saved as a text file. And finally, if you click on close, your model will be updated in the this thing. So all your element beam loads are taken, pressure loads are taken actually, and plate thickness, solids and beams are imported, beam and offsets, beam offsets, plate offsets, boundary conditions, inclined boundary conditions, spring supports, everything are imported from the stat file actually. All types of supports, all types of loads except seismic and wind loads and floor loads, which are defined with Y range and X range. Apart from that, all the other things are imported to the program. So it's a little bit, it's a consist of a number of plates actually. So that's why it is taking a little bit of time. And whenever you importing actually any file and all, something, if some problem is there, you are not able to import and all, you can always watch the message window at the bottom. At the bottom of the screen, there is a message window. There, the warning messages or error messages will be displayed there. So either you are importing a ETABS file, S2K file, or any file actually, a Revit file, Tekla file, any file you are importing actually. So if you find, if you are not able to get the model working, you can check the message window. There, the error messages will be displayed at the bottom. So here you can see actually the concrete, the thickness of the plates and the loads, the pressure, upward pressure on the raft, downward pressures, all the pressure loads are also imported. So this is in brief about the stat import actually. Now coming to the modeling with the inbuilt functionalities in MIDAS Gen itself. So up to now what we have seen is how to import models from different softwares or how to take it with from the BAM softwares and all. Now we discuss about some of the modeling functionalities available in MIDAS Gen itself. So if you want to generate any type of model in MIDAS, the first thing is either if you have a grid, you can generate a grid actually. You can go to grids. So you can say point grid or line grid. And if you want to define your grid actually, you can go to the structure, define point grid. So you can give 1 meter by 1 meter grid. So boundary is 0 comma 0. Starting is 0 comma 0 and 10 comma 10. So 10 meters boundary I'm giving. Say OK. So the boundary is generated. Maybe the dots are not clearly visible. Just change me my display color to black. So now you can see the yellow dots actually. So directly now you can go to the elements, either create nodes. Directly you can snap to the grid points and you can create, or you can directly create elements snapping to the grid points. Or you want to create the slabs and all, actually you can go to the auto meshing. So node elements. So directly selecting on the grid points itself, actually the slab, the shape of the slab and all, actually any arbitrary shape of the slab. You can do the meshing. any arbitrary shape by selecting the nodes on the grid. So one way of modeling is using the grid, the point grid. You select the point grids and you create the model based on the point grids. The second option is you can also use the line grids. So grid, define line grid. So when you're using the line grid can be defined only in the XY plane. You cannot define the grid in the XZ plane, any other plane. It will should be always in XY plane. So can you define your grid lines in the X direction? So what is the spacing? 5 meters and then 3 at the rate of 8 meters. When I say 3 at the rate of 8 meters, it creates 3 grid lines each at a 8 meters distance. So here actually there is at the top you can see another option, absolute or relative. When I say relative, the first span I give 5, the second one I give 5. So this 5 is with respect to the last point. When I say absolute, then I need to give 5, 10, 15 like that. Okay. So with respect to absolute I was giving, and here also I'm giving 3 at the rate of 6 meters. Okay. Okay. So and you need to give a name. Okay. Okay. So here you can see the grid actually. So the grid is placed. Once the grid is there, again you can create the elements and boundaries and everything on the grid actually. So wherever you want, you can place the elements, sections on the grid, and you can create the sections on the grid. So this is one way of modeling the grids actually. So yeah, I selected the beam name actually, and then on the grid lines, I was clicking on the grid line. So just for generating my beams and all in the grid line. So this is one way of creating the model using the grids. The other way of creating the model is we also have wizards actually. Different types of wizards are there actually. So by using the wizards also you can create. So we have beam wizard. So for generating a beams, column wizard, arch, frame. Arch is mainly useful for creating curved beams or curved these things are curved arches, parabola, circle, ellipse. Different types of options are available actually. So you can select any type of thing and you can implement the arch. Okay. Similarly, you can go to the base structure, frame structure. So here if you want to create a floor plan actually, floor plan directly you can create it here. Say 5 meters. 3 times I want to repeat. 3 at the rate 6 4 times I want to repeat. And then I go to the edit, generate frame. So the frame is generated. So I define a section property. Say it is I section, let it keep it I section, HEA 240. Okay. Close and insert. So here when you are defining the frame actually it is defined in the XZ plane. It's not in XY plane actually. So if you want it to be oriented in the XY plane then you need to give rotation with respect to the X axis, that is minus 90, and I would say okay. So here you can see the section is defined, the frame is defined. So this is one way of doing the frames actually. Truss, we have different wizards for the truss. Different types of truss can be defined actually. By using the truss wizard you can define the trusses and all. Or the other way of the modeling is directly you can create the nodes and elements and you can do these things. So here again once you create your frame or anything actually, if you want to create your columns and all, it's the same again. You can select the various nodes available and you can go to the extrude commands, extrude, and you can generate the model, extrude commands and all. So if you want to create any tanks, water tanks, or any circular structures and all, that's also you can use the extrude commands, rotate command, revolve command. All these commands are available. So for example I want to go create a water tank, circular tank actually. So what I can do is directly first I will create a node. I am creating a node at 5 meters from the origin in the X direction. So I just created a single node at that point. Now I'm going to the extrude command, extrude. I'm extruding my node to line element actually, node to line element in the translate direction, unequal distance in the z direction, 3 times at the rate of 1 meter, at the rate 1 meter, and select the node and I would say apply. See the line is created. Now what I will select is similarly again I will select the node at the top, x and y 1 meter, say 5 times, and I would say apply. So my inclined surface I created. Now I select the top face, again I say 15 at the rate of 1 meter. So what I was creating is just I was creating a 2D line for my entire structure, tank structure. So once the 2D line is created, I can revolve this to create the circular structure. So I select the complete line, line to planar element. So I select the complete elements, line to planar element, and then I would say rotate number of times. Let me say it is 36 times. Increment angle is 10 degrees. Rotation axis along the Z axis. I select all the elements and I would say apply. So the structure is created. So this is one way of creating. So similarly, again, what you can do is if you have solid elements, say for example, instead of 36 times, I would say 2 times 10 degrees along the Z axis, selecting the elements. So these are the planar elements created. Now I can convert this planar element to solid elements as well. So I select the planar elements, solid elements. So translate in the x direction 2 at the rate of 0.5 meters, 0.5. I would say apply. Okay. Yeah. So once I select the plates actually, and I can just rotate it, so I extrude it. So this can be extruded into solid format as well. Solids. So the plate elements can be converted to solids. Solids can be converted to solids actually. The nodes can be converted to line elements. Line elements can be converted to planar elements. Planar elements can be converted to solid elements. So this is the basic modeling actually. The different types of modeling techniques available in the software. Now coming to the other things like some of the other modelings like the slab modeling and the meshing of the slabs and all. So for example, if you want to, if you have already created the floor plan actually with all the column locations and all. So let's see, this is the floor plan where I have my beams and the columns actually. So let me go to the hidden view. So I have my columns and the beams. The outer periphery beams are there and the walls are there. So in this case, if I want to generate my slab actually, I can use the auto meshing functionality as well. So you go to the node by element, auto mesh. So it's a line elements. So one option is I can directly select by plane. I can select the entire XY plane and I click on any node on that plane actually. So the entire plane is selected and I say close and I would say apply. See, the meshing is generated. So like that you can go on generating the meshing at different places actually, and you can create the model. Once the meshing is generated, now you want to generate the building. So again you can select the complete model and you can go to the structure, control data, building, say 3 times or 4 times, 3.15 meter height, say add and you say apply. So in some portions actually after going towards the top, you don't want your complete building to is not being going towards the top. Only some portion of the building is just going to the top actually. So in that case, what you can do is there is no, either you can import that floor plan from again AutoCAD and you can do it, or you select only that portion of the structure and you go to the building generation operation, say 3 times, yeah, 3.5 meters, add, only select the portion which you want to extend and you say apply. So only that portion is generated in the building. Okay, this is how you generate the models in MIDAS Gen. So if you have any doubts, actually you can ask. So this webinar is mainly concentrated on the modeling. So next webinar we will be conducting with very soon within 15 days. We will send you the invitation file. There we will be talking more about the loadings, different types of loads, how you apply the loads in MIDAS Gen and all. The loading part will be covered. So in modeling, if you have any doubt, actually you can ask me. Up to the modeling or import related functionalities. If you have any doubts, you can ask me now. Is it possible to include parking ramps to be imported to MIDAS Gen? Yes, sir. You can import the parking ramps actually. Yes, you can import the parking ramps, but that should be from a 3D file, not from a 2D file actually. If you want to go it from the one floor to another floor, the ramp is going. So then it should be in the 3D file actually, not in a 2D file. Yes, sir. Offset of column is there actually. There are different ways of providing the offset for the columns actually. Say for example, okay, I will show you how the offsets are provided to the column. So I would take a very simple example here actually, where what I will do is actually, let me, okay, I will do a simple column actually, where I have a column at the bottom, which is 500 by 500, say, or a 1 meter by 1 meter at the bottom column, and the top column is 500 by 500, which is meshed of, which is flush to one side of the column actually. So if you want to provide this type of offsets, yes, you can do it in MIDAS. Just I will show you a simple example how it can be done. Just let me. So here what you can do is first let me create two sections. I go to the properties, section properties, add, say, solid rectangle, column, 1 meter by 1 meter, apply, and another column is zero point 0.5 by zero point 0.5. Okay. Now what I will do, I structure, base structure, column, say 2 at 5 meters, sorry, 5 meters, 2 times, add, material 1, section 1, okay. And now the top column I'm going to change it to column 2. Now by default actually it's always the connected center line to center line if you see here. So there are two ways of providing the offset for this column. One is you select this thing and you go to the boundaries. We have option called beam and offsets. So here you can select the beam and offset. In the global direction you can give the value, what is the RDY, in which direction you want to move, RDX, RDY. That is one way. Or the second one is directly you click on the right click on the property. When you are defining the property of the column itself, there we have this option called change offset at the bottom. So click on the change offset. So you can say it's in the center, it's like center bottom. Center bottom. Okay, it's not center bottom, it's center top actually. So bottom has gone to that side. So if I want to take it to this side, center top, okay, okay. So here you can see the column is automatically flushed to the other end actually. So now once you apply what are the loads are coming and all, it creates additional movement in the column below. So if you see in the 3D view, it shows like this, but if you see in the line view, it is similarly a straight column again. In the line view, it is straight, but if you go to the 3D view, extruded view, you can see the column. So you can give different offsets for different positions for the columns. Not only for columns, you can give offsets for slabs, plates. So for example, you have sunken slab and all. On two sides, the slab is at different level for the beam. So those things also you can model here. Yeah, the question regarding this is, and there is a connectivity and no need to connect them. Yes, sir, there is a connectivity internally. There is no need to do any connectivity or anything. These two columns are connected. Now, similarly, if you want to do, say, slab, sunken slab, actually something, which are the slabs are at different levels on both sides of the beam, it is at a different level. So what I can do is actually just I will go to the point grid. Let me create two slabs actually. Say structure. Let me go to the node by element, create elements, planar element, plate. Sorry. This is the slab on one direction. This is the slab on the other end of the beam. And then I have a beam in between. Say general beam by tapered beam. This is my beam. So what I will do is just I will close this thing works. First let me define the beam property. Let me say it's a solid rectangular beam. Say beam. Say rectangular height is 700 mm beam actually. Thickness is 0.2, let me say. It's a beam thickness. So let me go to the this view actually. And the plate thickness, add 0.2 thickness plate offset, thickness or value 0.2, That is 0.1, 0.1 plus 0.35. This is 0.25, I think. Okay. Add another thickness 0.2 and plate offset value minus 0.25, and I would say okay, and I select the second plate and apply this thickness. So like this also you can model actually. So here the slab actually it's in the same level, but it is like a due to different. If there is a loading difference is there on the both ends of the slabs, it creates the movements and all. So it's not only the offsets for beams, columns, you can do it for slabs, walls, and everything. You can give the offset commands. Okay. And another question from Mr. Ahmad Tarawan hai, when you select the old story to replicate it, will the selection include the fixed support? Yes, sir. By default, the selection include the fixed support, but here the option actually when you are going to the building generation, at the bottom, we have the option copy node attributes, copy element attributes. If you uncheck this one, none of the node attributes are copied actually. The supports are not copied, but if it is checked, then the supports are copied. So if there is some load is also applied on the node, you want to copy the load, you don't want to copy the supports, then what you can do is next to this copy node attributes, there is a small box with the three dots. Click on that. So it opens. So here you can check which one to be copied, which not to be copied. Say I don't want to copy the supports, just I can uncheck the supports actually, and I can keep the loads, the static loads and nodal masses. So those things will be copied. The supports are not copied. So you can manipulate these things actually when you're generating the building and all, which one to copy, which not to copy and all. So it's not only for the nodes actually, even the elements, element attributes. If you have given any beam plate releases and all, either you want to copy the plate release, the beam releases and all. Similar the building attributes like floor loads and all, you want to copy the floor loads or not. So those things you can check. Any other questions? So any questions, sir? Any questions if you have, you can ask me the questions. So if there are no further questions, we will end the session here. Thank you very much for attending the session. So if you have any doubts or any questions, actually you can send the mail to techsupport@midasit.com. That is our technical support ID. So immediately one of the engineer will reply to you. So in future, if you when you are working on the program, if you have any doubts or anything, actually you can come to the techsupport@midasit.com. That is our technical support ID. And another question, does the converter need a specific window to work like Windows 7 or Windows XP? Sir, you are talking about ETAPS 2013 converter? If it is the ETAPS 2013, yeah, ETAPS converter, it will work in Windows 7 or Windows 8, Windows 10, any of these systems it will work actually. And it should be, both your ETAPS program should be 64-bit and your Windows should be 64-bit. Both should be 64-bit. And from Mr. Rafi Akhtar, can we get the video clip? Yes, sir. After the presentation, the video is being recorded. We will send you the video clip. Actually, this clip will be sent to you. Mr. Ahmad, I will give you a call and I will talk to you actually. After this webinar, I will give you a call in another 10 minutes and then we'll discuss about the converter problem you are facing. So if no questions are there, we will end the session here itself. Thank you very much. Thank you for joining us. So if you have any questions, you can just write to me.